Okay, so let us continue with the discussion in advanced SQL. So we are done with joints. So now let us continue with subqueries. So when you say subquery, it is a counterpart of join. So basically, when you say subquery, it first exists. Subquery was first used to process multiple tables. Then join came later. Okay, so before join existed, this subquery is being used to process one or more, I mean two or more tables. So when you say subquery, it is placing uh, an inner query inside an existing query. So that is a select query within a select query. So it can be placed either in the where clause or in the from clause or within the having clause. Or it can also be placed in line with your select query, depending on what output you wanted to achieve. So also, subqueries can either be correlated and non-correlated subqueries. When you say non-correlated subquery, the inner query will not depend on the data derived from the outer query. So the inner query can stand on its own or can be executed on its own. On the other hand, when you say correlated query, the inner query depends on the data from the outer query before it can process it. Okay, so let's have some illustrations and discussions for subqueries. So this is an example of a subquery. So you wanted to show all the customers who have placed an order. So in this case, you have the outer query, you have here the select customer name from customer T, and then the inner query is placed in the where clause, where customer ID in, select distinct customer ID from order T. So the in operator here is used to execute the subquery. So the in operator will test to see if the customer ID value will be included in the output of the subquery. So let's try to illustrate that one. Okay, so in here, let's try to illustrate using the bike factory database. It's the same database that you will be using for your activity number 2. So you have here select customer. It's not customer name that we used here. It's first name and last name, if I am not mistaken. Yeah, so customer ID, first name and last name. So select first name, last name from customers, where customer ID, then we have the in operator, in, then we will do the inner query or the subquery. Select customer distinct. When you say distinct, this is a special operator that will only give you the unique value of each customer ID. Now distinct, you can use distinct or you can have not. So select customer ID from orders table. Is this the same query that we have? Yes, from orders table. So if we will execute this one, here's how it looks. Notice that the inner query here is being executed first to check for a customer or to get or to extract the customer ID from the orders table, and it will compare it with the customer ID from the where clause. If both is equal or if they have matching records, then the first name of and the last name of that customer ID will be displayed. Okay. So what have you noticed? It looks like join, but it's more complex. The code looks like more complicated than join. Okay. So let's try to execute this code using join. Just a simple join. So you have your select customer. This. Oops, I'm not using the same database here. Let me use by factory. So I have here select see that first name, see the last name from customer C. Join orders, join orders on or on see that customer ID is equal to all that customer ID. Let's try to check the what do you call this one output. So see, you have similar output with join. It's just that you each orders with the same customer ID has been repeated. But of course, you can choose to have it non-repeating by using the distinct special operation. Okay, so let's go with the query. I mean subquery. Okay, so now that is to answer the join and the subquery. What do you call this one? Syntax, or how it looks like when you use the join and how it looks like when you use the subquery. So if you are going to ask which is better to use, I will say when it comes to processing time, it's better to use join. Join performs faster compared to subquery. And for me, join is easier to implement compared to a subquery. But there are really instances that subquery will be used instead of join. But it's very, very rare because the most of the capacity of subquery is being inherited by the join operation. So let's go to correlated and non-correlated query. First, to define what is a non-correlated query. When you say non-correlated query, the inner query is not dependent on the data from the outer query, and it can execute once for the entire outer query. So see, inner query will be executed once for the entire query, for the outer query, while the correlated query, the data from the outer query will be used in the inner query. So the inner query will process each row So isa-isahon niya pag-execute line by line. Okay? Whereas in non-correlated, it executes as a whole. Once lang niya execute ang inner query, then the result of the inner query will be applicable to the outer query or to the main query. When you say correlated query, the outer query will be executed first, then whatever is the output will be used in the inner query. So it will be executed per record or per line of the query and per record in the database. So if you have 100 records, it will be executed 100 times. Okay, so correlated query can usually be used with the exist special operator. So in our example a while ago, this one, this is an example of a non-correlated query. Why? Because the inner query does not depend on the output of the outer query for it to be executed. So if you will check, try to go to our what to call this one. Let's go to our query. So notice here that if you will execute the inner query, if you will execute this, it will give you an output. Automatically, it will give you an output. Meaning that this inner query does not depend on the output of the outer query for it to be executed. So the behavior of SQL is to execute first the inner query in this case. So you have to take note that when you're going to create a subquery, you have to enclose it in a parenthesis. And you can create as many subqueries as you wish to, depending. So in this case, we are only involving two tables, the orders and the customers table. So you can have 3, 4, 5 subqueries. You just have to enclose it in parentheses. And you should know specifically where to place the subquery for you to get the output that you wanted to achieve. So in this case, we have a sample of non-correlated subquery. So the inner query is executed once so that it can be used in the outer query once. So it's executed as a whole. Whereas in the correlated query, when you say correlated query, the inner query will depend on the data that will be extracted from the outer query. So this is your inner query and this is your outer query. So whatever is the output from your outer query is dependent or will be used in your inner query. So the subquery is testing for a value that comes from the outer query. Okay, so select distinct order ID from order line where exist. So it will check exist operator here will return true if such value is present. Kung unsay value nga ma-derive ni outer query is present in the inner query select. If present, it will display that particular record. Kung dili, if it returns false, meaning the record generated or the data generated by the outer query is not found in the inner query, then it will return an empty set. Okay, so let's have here an example of a, what do you call this one? Of a correlated subquery. So let's use still the bikes database. So I have to look for my Codigo. for me to do the illustration. So let's go for what they call this one, the tables orders, for the table orders. So this is for your correlated query. So I wanted to display the store ID, or the order ID rather, from the orders table, given that that order ID has an order date between January 1, 2016 and March 31, 2016. So I have here select order ID from the table orders, where I have here exist operator, exist, select, order ID from orders, where order date is greater than 2016 January 1, and order date less than 2016 March 31. Or, so in here, what I wanted to display are all the order ID that is between, or that has been placed between the dates January 1, 2016 to March 31, 2016. Let's try to execute this one. Okay. So I have here the order ID. Okay. So the order ID that has been displayed are between, or are those placed between January 1, 2016 and January 31, 2016. So this is an example of a correlated query. So how does it work? It will first execute the outer query, this part here. Okay. Once all the order ID from the orders table are extracted, then it will check one by one. So if you have 100 records, so record number 1, okay, 1481, example 1481. I will check it with my inner query. I will check if the order ID 1481 was placed between the dates January 1, 2016 and March 31, 2016. If yes, then it's part of the output. If no, it will not be part of the output. Okay, so take note, i-execute first the outer query, then one by one, it will be passed on to the inner query for checking. So if you have 1,000 records, then it will execute the inner query 1,000 times. It's the opposite of correlated query. Correlated query, execute first the inner query once and compare it with the outer query. Okay, so as you can see, correlated query is much more slower compared to non-correlated query, because the inner query of the correlated query is dependent on the output, or on the data that will be extracted from the outer query. Okay, so that's all for subqueries. So if you will check the what they call this one, the slides, you can either use, you can have an example of a subquery placed in the from clause. Most of our examples are placed in the where clause, or you can put a subquery along with your outer query. Okay, so that's all for the subqueries.